All right. Good morning, everyone. I know there are a few people still hopping on the webinar, but we're going to go ahead and get started. My name is Carissa Eatman, and it is my pleasure to welcome you to today's webinar, Removing Data Science from the Ether. Before we get started, I want to go over a couple of logistical notes just to set the stage before we begin. There is a Q&A window that you will see at the very top of your Teams platform. If you have any questions along the way today as we're going through the presentation, feel free to put those in there. I'll be monitoring that area, and we want to make this presentation as interactive as possible. So if anything comes up that you can think of that you might want some clarification on or a little deeper knowledge on, let us know. We're going to keep those going throughout the presentation, but we'll also save some at the end. There's also a chat area if you would want to have a side conversation, but questions, we would prefer you to put them in that Q&A so we can make sure to get them addressed. First and foremost, also before we begin today's presentation, we wanted to give you a little background on Keller Schrader. We know that even with our long tenured clients, there is often a little bit of misconception on the full breadth of what our company can do. So I wanted to cover that really fast to give you familiarity with all of the services that we can provide for you. So we are a company with 4 different divisions under our umbrella. We have applications, data strategy, which you'll hear more about today, infrastructure, and staffing. That makes us very unique in our space to be able to offer all of those different solutions for our clients and prospective clients. They are pretty self-explanatory, but applications that includes writing custom applications, mobile applications. They do a lot of custom integration. They can manage a website. There's also a lot of product management that team does. Data strategy, you will hear more about here in a minute. That's the group that we're featuring today. Infrastructure is route switch, voice solutions. Our security solutions group is also housed within that business unit. And then staffing, those ladies specialize in technical recruitment and placement of an IT professional. So if you have a specific skill set that you're looking for either to hire or if you need them on a contract basis, our staffing team can help you with that. So with that, let me introduce today's presenter, Will Hawkins. Will is a senior data scientist in the data strategy group at Keller Schrader. He has a passion for helping organizations of every size and data literacy level to harvest value from their data. Prior to entering data science consulting, he attended the University of Kansas for his PhD, in applied physiology. And it was there that he first developed his passion for statistical programming. When he isn't at work helping clients manage data, do science, and get better, you can find him on the golf course or smoking meat. So please help me welcome Will. We're going to do a little presentation switcheroo right now, so you might see some behind the scenes things happening.
Thanks so much, Carissa, for that introduction.
Oh, excuse me. That's my fault.
All right, so as Carissa just indicated, my name is Will Hawkins, and I'm a senior data scientist in the data strategy group at Keller Schrader. And our tagline is simple. We help organizations to manage their data, to do science, and get better. And practically what that means is we do everything from helping organizations build out 5-year strategic plans surrounding big data to actualizing every part of that strategic plan, whether that be building out new storage solutions, ETL solutions, data science, machine learning solutions, dashboarding, all of those things. So today's talk is on data science and specifically attempting to kind of remove it from the ether. I think that data science, AI, machine learning probably rival like blockchain in the sense that they inundate your LinkedIn feed. They're all over the news. But I think that aside from like 5 organizations that do it at an extremely high level, I think a lot of times smaller organizations really struggle to understand like how do these really advanced kind of sexy technologies apply to my organization. So here I have some screenshots, like in the top right corner, you have Boston Dynamics with their autonomous robots. In the bottom left, we have ChatGPT, again, a technology that is no doubt impressive. We've probably all toyed around with it, but it's like, how do I take this really cool tech and apply it to my organization? We see the same thing with Tesla, with autonomous driving. And I think that organizations are really interested in AI, machine learning, and data science for several reasons, but perhaps the most pressing one is fear of becoming obsolete. If you've paid any attention at all over the past 10 years, you've seen serious disruption in several industries. We've seen Uber use AI, machine learning, and data science to automate the matchmaking process between people who have cars and people that need a ride. And that's completely disrupted the taxi industry. We've seen very similar things with Grubhub. Then Amazon has obviously turned retail on its head by using data science to better target customers for advertising, and then also to make it where you can order a package and literally receive it in some cases in hours, if not in a couple days. So again, those are all very lofty kind of use cases that might intimidate a lot of organizations. Maybe you're an organization that builds industrial mining equipment. You have no aspirations of building autonomous robot dogs or sending something to Mars. You're interested in how can I better order to keep my supply chain just-in-time process going. So today I'm going to take you through a pretty simple machine learning use case. So let me kind of frame this use case. So I'm going to be using a coding language called Python. We're not going to really hone in on that. There's lots of languages. That's not really important. But today we're going to be dealing with this data set that you can see visualized, where this is a crime data set from the city of Vancouver, Canada. So this is real data. All of their crime data is publicly accessible. This is about 10 years worth of data and is, I believe, 80,000 records. So we can see like type, which is the type of crime. We have year, month, day, hour, minute. So that just gives us an idea as to when the time or the crime occurred. We have the block, so which block in the city of Vancouver did it occur within. We have a specific neighborhood name, so again, just to identify a region. And then we have GIS information, so XY coordinates, as well as latitude and longitude. So I need to switch over real fast, maybe. Okay, so again, this is in Python. I'm currently using something called Jupyter Notebooks. We're not going to hone in on that, but Jupyter Notebooks just allow you to write and execute code inside of a browser. So it's perfect for things like this, where I want people to be able to see the code as well as what it's producing. So again, let's take just a quick scan at this data. We just looked at it. Basic crime data from the city of Vancouver. So for this analysis, I'm going to kind of put on the hat of I am the mayor of Vancouver. One of the things I'm tasked with is crime reduction. So I'm going to do now a basic exploratory data analysis. Exploratory data analysis is exactly what it sounds like. It's taking a data set, kind of turning over stones, seeing what you find, and as you find things, kind of um, interrogating the data, diving deeper, starting to come up with some research questions, and maybe finding some insight that you can use to automate a process down the line. Okay, so let's look at the types of crimes that are occurring. So here I can see that 33% of crime that was reported was theft from vehicles, 13% was mischief. I don't exactly know what all that entails. Your guess is as good as mine. Then we have 11% breaking and entering. So again, I have the hat of being the mayor of Vancouver on. My KPI is probably total crime volume. So if I'm wanting to move the needle on total crime volume, I probably want to zoom in on this theft from vehicle. There's a lot of that occurs, and it seems like something that intervention could move the needle on. Okay, so now I'm going to do a little bit of diving on neighborhoods. So let's look at the distribution of crime by neighborhood. So here we see that about 23% of crime is occurring in the central business district, which is roughly 4 times the amount of crime that's happening in the second most crime dense neighborhood, which is the West End. So that is of interest to me. As the mayor, I probably don't want crime anywhere, but I especially don't want it in the central business district. So that's something of note that I'm going to jot down. So now I'm going to really hone in on this theft from vehicle. So one of the first things I want to do is I want to understand, where is this crime occurring in my city? So there's lots of ways to visualize GIS data. You could do this in a dashboarding tool like a Power BI or a Tableau or a TIBCO Spotfire. Just for speed and simplicity in this analysis, I'm going to do it using pure Python. So I basically am ingesting a file that has all of the GPS coordinates for the boundaries of the city of Vancouver, and I'm plotting that here. So if you're following along, you probably know what I'm going to do next. And that is plot the crime on top of that map. So these red dots represent crimes reported, and I'm plotting that over the city of Vancouver. So my big takeaway here is crime is not evenly distributed across the city. We see that there are pockets of there's pockets in the city where crime is occurring at a higher rate. So down here, it seems like in a lot of the coastal regions, we have more of these car break-ins. But again, my big takeaway is it isn't evenly distributed throughout the city. So when I'm building a solution that hopefully reduces car break-ins, we're going to keep that in mind. So let's look at time of day as well as date. So for my time of day, these are all in military time. So 18.0 represents 6 p.m. See roughly 9% of crime is occurring during that hour. I'm not really seeing a trend here. It does seem like kind of early to mid-evening is when most of the crime is occurring, and down here in the hours where literally no one wants to be awake, like 3 a.m., 5 a.m., there's almost none of these break-ins that are occurring. But again, there isn't anything that's real, like stands out to me in this part of the EDA. So let's look at days of the week. Again, I don't see a ton here. 0 represents Sunday, 1 would then be Monday, 2 would be Tuesday. And I'm not seeing anything really substantial in the distribution here. So I could, again, like do a hypothesis test here to um, tell you exactly whether there is a statistical difference between days of the week. But I can tell you just from looking at this plot that there isn't really an analysis here. Let's look at some simple correlations. So if you've never interpreted a graph like this, um, basically you'll look at your variables on your x-axis. So I'm going to look at hour, and then I'm going to run up to longitude. And the intensity of that blue tells me the correlation, where a 1 would be a perfect correlation. A 0 would be they're absolutely not related. And there really isn't anything with high correlation here. Something that would have been interesting would have been, maybe there's a correlation between the hour that the crime occurred and the latitude and longitude. That could indicate something like, in the evenings, there's lots of crime in the Northeast. And in the mornings, there's more of these break-ins occurring in the Southwest. That would have been interesting, but I'm not seeing that. Probably my favorite visualization is this one, and this is attempting to look at seasonality. So here on the x-axis, we have our months, January through December. On the y-axis, we have the day of that month. And as far as interpreting these boxes, you can either look at the numbers inside of the box, which indicates how many car break-ins were reported on that day, or you can look at the intensity of the color, with dark red being the highest crime, dark blue being the lowest crime. So there actually is some seasonality in this data where June, July, and August have the highest amount of car break-ins. We can guess maybe it's, kids are out of school and don't have supervision. We can, make guesses. We could do something better than guessing and really interrogate the data, um, which we will here in a second. So this is great. We, wrote some code, sliced and diced the data a little bit, saw some, or we learned some things about the data set, but learning isn't enough. We have to actually change our processes based on what we learned. So how do we do that? I'm going to build a machine learning model here to do just that. So the most interesting thing in this data set is this plot here, where we see that there's an uneven distribution of these car break-ins throughout the city. Okay, so again, I'm the mayor of Vancouver. I meet with the police force, police chief. He says, yes, lots of car break-ins. The best way to combat these is through passive surveillance. You may have seen in your city, they have these towable camera systems that you can put in a parking lot to help monitor what's going on in that parking lot, help deter things like breaking into cars. So the police chief tells me, we have enough money to buy 10 of these, and you're tasked with telling me what are the 10 locations in the city that we should deploy them to have the biggest effect on reduction of these car break-ins. Okay, so this is starting to sound a lot like math. This is moving away from intuition. Intuition has run this organization for a long time, and clearly there's still lots of car break-ins. So let's try using some math. So again, we're not going to get into the nitty-gritty of the math here, but I'm going to use a technique called k-means clustering. And so what clustering does is as the name implies, it will cluster groups of like instances of crime together. So in this instance, I'm using latitude and longitude. So what it's literally going to do is it's going to put 10 dots out on this graph because I have 10 camera systems. It's going to put 10 dots out here, and it's going to move them around, millions and millions and millions of times, and it's going to take the total distance from any individual crime and measure how far it is to the closest camera system. And it's going to do that for all 80,000 pieces of crime, and then it's going to move the dots slightly. And it's going to be solving for the math of how do I reduce the total sum of distance between all of my crime to all of my camera systems. All right, so let's run the model or train the model. So here I'm using a Python extension called scikit-learn. Again, we're not going to get into the weeds of what that is. You can do this in Python, you can do this in R, you can do this in Scala, lots of different ways. So here I'm training my model. It should take maybe 5 more seconds. All right. So I trained my model, and then I printed the resulting 10 locations of where those camera systems should be. So these are in latitude and longitude. So this is good. Now I want to overlay those on top of the map that I had. So this is mathematically the optimal location for these 10 camera systems. Okay, so let's say that there's, within the organization, there's different theories about what's the best way to intervene. One person says it's camera systems. Another person says, well, we should really buy signage and we should put it out there, and coach people up on don't leave your backpack in your vehicle. If you're going to leave something in your car, make sure it's covered. Okay, let's test both. So I could run this same algorithm. Let's say we have 5,000 signs. I could run the same algorithm to know what is the 5,000 best locations for those signs. And then I could take it a step further and I could use something like an ANOVA to do an A/B test to know which one of these interventions was actually more effective. Again, taking kind of intuition of, I think this is best. Oh, well, I think this is best. Well, let's see which one actually turns the needle more. So, how could this be built into an end-to-end solution? Like, this has been a cool little demo, but how could this actually be deployed? So, Um, I was reading the crime data in as a CSV. You could easily have that data being dumped into a database environment where you could have um, a trigger that is daily, weekly, monthly, going out and grabbing the updated data from that source system, pulling it into your model, retraining the model, spitting out the 10 new optimal best locations for your camera system. And you could take it a step further and have it spit those GPS coordinates into a Power BI dashboard where all the commissioner has to do is open his Power BI dashboard, know what's the optimal locations this month for these camera systems, and have his people tow the camera systems to the new location. So that was a cool kind of custom one-off analysis and explanation of how you could potentially use machine learning in your organization. But there's lots of money that has been spent already to build AI models. Do you necessarily need to spend the time and money to build your own custom deployments? It just depends. So Google Cloud, Microsoft Azure, AWS, they all spent over $1 billion last year on AI research. And I'm going to venture to say you do not have $1 billion budget. So there is a reasonable chance that if your use case um, requires a common AI task, that your best bet is not to build a custom solution, but rather to use one of their API services. So things like speech to text. You do not need to build a custom solution. There are several solutions out there where you can send a WAV file or another audio file and it will return um, text to you. Same things with common language models like sentiment analysis. You don't need to build a custom algorithm for that. You can easily pipe your Yelp reviews or whatever you want to do sentiment analysis on to one of these APIs, and they will return analysis scores. Same thing with computer vision. It is extremely expensive to train your own custom AI solution to annotate video or segment images. You should probably not build your own custom model, but these API services are going to be much quicker, much more affordable and more accurate. Same thing with decision science, things like anomaly detection or fraud detection. AWS SageMaker, for example, has a pre-built fraud detection algorithm where if you send de-identified banking transaction data to their API endpoint, it will return a flag column of fraudulent or not fraudulent. And then lastly, these screenshots have come from Azure's Cognitive Services, which is their AI microservice offering. So Azure is interesting, especially because they own a large stake in OpenAI. As you know, OpenAI owns ChatGPT. So if you have interest in accessing ChatGPT, whether that's for some sort of internal search engine you may have, or whatever your use case is, you can access through Azure Cognitive Services. So thank you so much. I could talk about this all day. Hopefully I didn't, and we have time for questions. Yeah.
I don't have a question so far in here. Does anyone online have a question for Will about either the use case that he presented, data science in general, more about our data strategy group? It's looking like you covered it all in our presentation. So again, as Will mentioned, if you have questions or you want to start a conversation with our data strategy group, you can reach out to Will. You can visit us on our website and our contact us page. You can also reach out to your Keller Schrader account manager, and we'll be happy to get that started. So thank you very much, Will, for today.
Yeah. Thank you.
Yeah. And this presentation, we recorded it, so it'll be available along with Will's slide deck if he's comfortable with it after. Oh, we did hit a question just now, right as we're wrapping up. So isn't this the same as data mining? Can you explain the difference?
Yeah, so I would say data mining was a part of this. So data mining will be like going out and accessing and a lot of times cleaning data, which is the first step in any sort of machine learning or data science project. But again, data mining is more focused on accessing data a lot of times from multiple systems. So maybe you're grabbing some from this SQL table, some from this SQL table, you're joining that, then you're going out and parsing data from a CSV that exists in an S3 bucket. So I would say mining is more focused on how do you collect, aggregate, and clean data.
Thanks for that answer. Any other questions before we wrap up? Okay, well, thanks everyone for joining us today. Again, we'll make the recording and the slide deck available to you following the presentation, and we really appreciate you taking the time today to join us.